Namaste. Welcome to this session of precession of equinoxes and the Ayanamsa as per the ancient Hindu astronomy. For getting into this subject of precession or the subject of Ayanamsa, which is a very important topic in Hindu astrology, we will look at the basic concepts which are required to understand precession. The concepts we will recap are Earth's rotation revolution, the Sun, Moon and planets, their orbital path, the Earth's axis and its movement, axial precession, what is meant by geocentric and heliocentric astronomy, the zodiac as per the astrological terms, tropical and sidereal systems of astrology. With this recap, we will be ready to get into the subject of the precession of equinoxes and the precession as per ancient Hindu astronomy. We all know that the Earth rotates around its own axis in a period of 24 hours, very close to 24 hours. It's a very minor difference of the length of the day. And at the same time, it goes around the Sun in a period of around 365 days. The Sun also makes a movement with reference to the Earth at about 1 degree per day. And we find that the Sun apparently looks like it is going around the Earth. It daily rises and sets according to the rotation of the Earth. At the same time, according to the year, it moves in the sky also. The Moon revolves around the Earth and causes the full moon and the new moon, and which causes the month. Therefore, the calendar is based on the movement of the Sun, Moon and Earth. As the Sun is apparently going around the Earth and the Moon also is apparently going around the Earth, we call this system as geocentric, or the Earth as the middle of the heavens. However, we know in reality the Earth goes around the Sun, the Moon also goes around the Earth. Since it is going around the Earth, it also goes around the Sun. These two bodies, which are primarily affecting the Earth, causes some pulls on the Earth, changing its rotational path. The Earth is not a perfect sphere. It is slightly bulged at the equatorial portion or the middle and flattened at the poles. The gravitational or the magnetic pull of the Sun and the Moon is more on this bulge trying to align the equatorial plane with the Earth's orbital plane. It does not actually change anything on the orbital plane. However, causes the Earth's axis to wobble. The wobbling is similar to a spinning top. All of us who played tops in our young ages will know that since the top does not have a perfectly regular shape, as this top is spinning, we will see that its axis is also making a small circle, and this circle will become more and more pronounced when the speed of the top comes down. This motion of the axis is called the axial precession of Earth. That means the Earth's axis will make a small circle around itself in a conical fashion, and it takes around 25,800 years to complete this full circle, which makes it approximately 50.2 to 50.4 seconds of arc per year. Seconds here is not the unit of time, it is the unit of the angle of arc. Degrees, 1/60th of a degree is a minute, and 1/60th of a minute is a degree. That is 3600th of a degree is a second. So the sun's pull is causing around 16 seconds of movement, and the moon creates around 34.4 seconds of movement on the Earth's axis. It is astonishing to see that the text Surya Siddhanta of the Hindu astronomy, written thousands of years before Christ, estimated this precession at around 54 seconds of arc per year. Thousands of years before Christ, when world did not have any idea of scientific thinking, neither civilizations have not developed. The Indian civilization and the Hindu scientific thought have developed so much that they had estimated the precession by their devout observation of the heavens. We will see what here now discussed in a diagrammatic form. This circle is the ecliptic, where the sun, moon, other planets are seen to move around the earth. Looking at the sky, we can see the planets move every day, or the sun and moon move every day. This earth is at its center, and this circle is around it, where the planets are moving. Around the center of the earth there is another circle, imaginary of course, which we call as the equator. The center of this ecliptic and the center of the equator are at a coincident place. And these two are inclined to each other at 24 degrees. Actually, it is 23.37 degrees or something like this, more precisely, but approximately 24 degrees. And this line, which we see here, passing through the center of the earth, running north-south. Here it is running east-west from the earth's point of view. The line running north-south is the axis of the earth, and as you project it towards the sky, it is pointing to a star called the pole star. That point is called the celestial pole of the earth. And similarly, there is another line which is passing through the center, but inclined at 24 degrees, and this is the axis of the ecliptic, pointing to a fixed star. This point is called the ecliptical pole. Now you see the pole here, as we saw in the previous slide, is slowly rotating as the earth keeps on moving, and in 25,800 years it will come back to its original position. So in this way, what will happen is this celestial pole will be pointing out to different stars during the long period of 25,800 years. This pole is called the Dhruva Nakshatra in our Hindu astronomic science. Dhruva because it is fixed, but however it is not always fixed. After several years of human observation, means one human being cannot observe it. If you keep on carrying it on down the generations, after several thousand years, you will see that the present Dhruva Nakshatra has actually not there pointing to the north, but a new star has appeared. This is in a figurative term explained in Srimad Bhagavatam by the story that the Prince Dhruva was appointed to rule the heaven there, sitting near the Vishnupada, near Vishnu's feet. And after several thousands of years staying there, he will come back to earth again with another birth. And when he was granted the position also, he has to wait for several thousand years after ruling the earth only he could go there. So there is a Dhruva's position available after several thousand years, has been mentioned in Srimad Bhagavatam. As I already mentioned, the geocentric astronomy or astrology, the earth is at the center of all planets, and all the planets move around the earth. The sun and moon are also called planets. The zodiac, so far as the astrologers are concerned, is a sacred belt. It has got 12 constellations, group of stars, along the ecliptic, and the sun's path is passing through all these 12 constellations. These constellations are called signs or rashis, and they are reckoned from Mesha or Aries to Meena, that is Pisces. The group of stars contained within these rashis or within these zodiac signs are called nakshatras. So the zodiac belt starts with Ashwini Nakshatra and ends with Revati Nakshatra. There are 27 of these stars. There are actually not exactly 27 numbers. There are 27 groups: Ashwini, Bharani, Kritika, etc. are star groups. Now we'll see what is called the precession of the equinoxes. We already saw in the previous slide, in the geocentric astronomy, the sun and the moon and the planets are revolving around the earth. The sun's apparent path around the earth is the ecliptic. This is called Kranti Vrittam in Hindu astronomy. And the equator, which is at 24 degrees inclined to the Kranti Vrittam, is called the Vishwavritta. It is a circle bisecting the axis of the earth and passing to the center of the earth. Imaginary circle. The intersection of these two circles, there will be two places where they will intersect. If you look at it in the three-dimensional way, there is one circle around the earth and one circle 24 degrees inclined to it in the heavens, in the celestial sphere. These will intersect at 2 points. This point is called Sampada Bindu in our astrological terms. Sampada Bindu or Ayana Bindu. The point is called Ayana Bindu because it moves, and it is called Sampada Bindu because it is a point of coincidence. Point of coincidence of the two circles. The sun at this point, when the sun is at this point of the ecliptic, the night and the day on all places on earth is equal. That place is called the equinox, or the Sampada Bindu is actually called the equinox. The Sampada Bindu is assumed to be at the last degree of Revati and the first degree of Ashwini. That is at the junction of the end and beginning of the zodiacal circle. Why we are taking assumed to be is that the Sampada Bindu is moving, or the Ayana Bindu is moving. Therefore, it doesn't remain there, it's fixed there. But for all practical calculations, Hindu astrology uses it as the first degree of Ashwini or first degree of Mesha. The point is drifting westwards very slowly. Very slowly at the same rate of 25,800 years. This movement of this Sampada Bindu is what is called as precession of the equinoxes. The precession of equinoxes is caused by slow motion of the Earth's axis, the wobble and the conical motion making a circle in 25,800 years. This motion, how it is caused, we will see in the next slide. Now let us see how precession happens in a diagrammatic form. First, let us draw the ecliptic here, the circle around the earth, and the equator at 24 degrees inclined to the ecliptic, C being the center of the ecliptic and the equator. Now, the line drawn through C at the center of this ecliptic, we have already seen that is the axis of the ecliptic. The axis of the earth is inclined 24 degrees to it, approximately 24 degrees to it. And the poles pointing to a fixed star in the heavens, or PP dash for the ecliptic, and small p dashed for the equator. Now, if we draw a great circle through P, small p dash and small p dash, passing through all these 4 points, a large great circle through this is spherical. It is the sphere, right, in the heaven. You draw like this. It will cut the ecliptic at 2 points. It will bisect the ecliptic as well as the equator. This circle is called the solstitial colure, or the circle of the solstices. The solstitial colure, where it cuts the ecliptic, are called the solstices. The one closer to the pole is called the summer solstice, and the one which is away from the pole is called the winter solstice. And it also, the 2 points what we have seen, the intersection of the ecliptic and the equator, these two are called the equinoxes. Here the day and night are equal when the sun is here, I mean to say. And here it is the longest day and the shortest day. Now we know that when you observe, since daily the earth is revolving around its own, rotating around its own axis, all the heavenly bodies seem to rotate around it or revolve around it. So if you assume this as an arctic circle of the celestial sphere, then you will see that this pole of the ecliptic will slowly go around. Every day it will go around the pole. Now we all know from the previous discussion that the pole small p is moving around this equinoctial pole, ecliptical pole, at a very slow rate of 25,800 years through the arc PCA. And the solstitial colure also bisects the equator at 2 points called A and Q. Now when this pole is moving along the arc PCA, it assumes some new position every time in several years. And if you draw a circle, a new circle passing through the new P dash and the new position of P and the new position of P dash, a great circle, it will cut the ecliptic at a different position than what was before. That means the solstitial colure has moved in the ecliptical plane by a certain distance. Therefore, the point of Aries, or the point of the coincidence of the ecliptic and the equator, or the equinox, which we used to call, also shifts by a equal distance along this plane. For each position of a new pole, or each new position of the pole, The solstitial color will keep moving westwards slowly, which is imperceptible to us in our human life because it moves by around a degree only in around 70 years or so. And this equinox also keeps moving towards the west. This is the precession of the equinoxes. The zodiac reckoned from the actual Sampada Bindu, that is year on year the new position of the equinox is called the tropical zodiac or the Sayana zodiac. The zodiac which considers the first degree of Aries always as the starting point is called the sidereal zodiac. Sidereal means reference to a star. Nirayana means without ayana, without movement. Sayana means with movement. Western astrology uses the Sayana system, whereas Hindu astrology uses the nirayana system. The longitude difference between the tropical and sidereal zodiacs is called the Ayanamsa, or the distance through which the precession of the equinox has taken place is called the Ayanamsa. To prepare a calendar, a panchanga, or to prepare a horoscope, we need to know the Ayanamsa properly, because after we calculate the position of the planets in the sky, we have to bring it back reference to the first point of Aries as fixed. Therefore, we have to compute the positions of the current positions of the planets corrected by the degree of Ayanamsa to get the nirayana positions. This is why Ayanamsa is very much essential for the Hindu astronomy. In modern astronomy, the precession is continuous because we have seen it goes around in a circle. It's a continuous revolution of 360 degrees. Whereas in our ancient Hindu astronomy, the precession is said to oscillate or librate 27 degree west and east of the degree of Mesha, first degree of Mesha. Libration or trepidation is the term given to this oscillation of 27 degrees. Let us see now what the Surya Siddhanta, the most ancient Indian text on astrology or astronomy, says. In Triprasnadhikara of Surya Siddhanta, the sutra given Trimsat Krityo Yuge Bhanam Chakram Prak Parilambade. The circle of the stars move eastwards. The translation given by Reverend Burgess, I have reproduced here. I have particularly taken Burgess because Burgess is a critic of Hindu astronomy. He finds many flaws in the theories propounded by the Indian astronomers. So that is why he says theory which passage in its present form is actually intended to put forth. He is not actually believing what it says, but he says that his translation is like this. The vernal equinox librates westward and eastward from the fixed point near PCM, assumed as the commencement of the sidereal sphere. The limits of the libratory movement being 27 degrees in either direction from that point, and the time of a complete revolution of libration being 600th part of the period called Great Age, or 7,200 years. So that the annual rate of motion of the equinox is 54 seconds. Now the same passage translated by Bapudeva Shastri says the circle of asterisms librates 600 times in a great yuga. That is to say, all the asterisms at first move westwards 27. Then returning from that limit, they reach their former places. Then from those places, they move eastward the same number of degrees, and returning thence come again to their own places. Thus they complete one libration or revolution. In this way, the number of revolutions in a yuga is 600, which answers to 600,000 in a kalpa. There is another translation of Madhav Prasad Purohit of this in the same passage. He gives on a footnote, वास्तव में 27 अंश तक संपात चलकर लौटता है, इसमें आगम प्रमाण के सिवाय और कोई प्रमाण नहीं है. The libration or oscillation of the equinoxes within the limits of 27 degrees is an axiom, and there is no other proof. So in fact, he doesn't have a mathematical proof to it. That's what he says. Now, it is very peculiar to our mathematics texts in the ancient times. Even in Leelavati or Siddhanta Shiromani, everywhere we can see that a theorem given by our acharyas are not shown with any proof. Even some of the problems are not shown with their solutions. Because in the ancient Gurukula system of education, the theorems were written down probably in the palm leaves or something to reduce the effort of writing down many things. They will write only the sutra. The student is taught the proof and the solution, and later the student teaches his student and goes on. Generation to generation it is carried on. Therefore, only remembering the sutra was required. The proofs are to be learned from their masters. That was the idea of our education those days. Therefore, you will find most of the books do not have any proof. The British and Western scholars who studied the Hindu astronomy were actually astonished or surprised with several concepts which are not acceptable to the Western minds. Therefore, when they critically analyzed, several opinions came about. The libration was one of these points where an apparent rotational motion around an axis is pictured as an oscillation was not easily acceptable to the scientific mind. John Bentley, in his book A Historical View of the Hindu Astronomy, remarks that the interpretation is only wrong. There is an erroneous notion that appeared to be entertained by some who call the motion a libration of the equinoxes instead of a revolution. He says, the sutra actually says, the Ayanamsa moves eastwards 30 times in each Mahayuga. He also remarks that in all this contrivance, I see nothing that could support in the slightest degree the opinion that has been found by some that the author of the Surya Siddhanta believed in the liberation of the equinoxes. To substantiate his point, what John Bentley suggests is that the ancient Hindu astronomers actually followed a theory of an epicycle for the equinoxes. If you look at the zodiacal circle here, starting from Aries, Taurus, etc. onwards to Pisces, this also will represent the ecliptic, and the equinoctial point moving through this zodiacal circle to take care of its irregular motion. You can assume there is an epicycle, and the points C and A will represent point of no precession, and the point D and B as maximum precession. And this rotation of the epicycle will look as though in 7,200 years it will go through 27 degrees to the maximum and then 27 degrees on the other side, back to the minimum and then 27 degrees to the other side. Just to show the concept of the epicycle, this is the circular path through which a point moves, and there is another smaller circle through which the point is expected to be moving continuously while it is executing the larger motion. These type of epicycles are used for calculating the planetary positions and also to explain their retrograde motions. So if you now take the equinoctial point and its epicycle and the larger ecliptic here, you can see that while the circle is passing through the larger circle, the equinoctial point there seems to be oscillating. If you watch it, you will find that as it goes towards the west, first the equinoctial point looks as if it is going to the west, and then it is going towards the east, and then it is again going back towards the west. Although I have presented some of the skeptical views or disagreements of the Hindu astronomical thought from the European scholars, not all European scholars agreed with Mr. Bentley or others, and there were articles by authors to verify the logic of the theory of liberation. Now we will examine another possible explanation of the liberation. Let the circle ES1, E1S, this large circle, represent the ecliptic. P is its pole. The small p is the equatorial pole at any time, and the small p is going around in this blue circle around the equinoctial pole, and this circular movement is the precession. As the great circle passing through the two poles P and small p and cutting the ecliptic at 2 points S1 and S, this line represents the solstitial color. Now let us make two arcs ST and ST1 at 27 degrees and draw a line touching the circle of the precession at P dash and P double dash. P dash is at one position of the pole, P double dash is another position of the pole. These two lines will intersect the solstitial color at a point C. The choice of this 27 degrees is not very clear. Why? We will try to see later that the 27 degree was a right choice anyway. But the 27 degree was initially chosen probably because the recorded equinoctial movement was up to Kritika in our ancient literature. And Kritika is 26 degree 40 minutes away from the first point of Aries. So there is a reference at some point where this equinoctial point is at Kritika. Therefore, the reckoning of the stars was also started from Kritika at some point of time in the Hindu history. So 26 degrees 40 minutes had passed at one point of time in the equinoctial point. So the maximum point at later, it has never been recorded elsewhere beyond that. Therefore, it was again counted that up to 27 it could go, and later the first point of Aries was anywhere reckoned by our people. So these 2 points at TP double dash, this line, and T1 P double dash represents 2 great circles which intersect at C. Now, if you see any point on this circle, P0 or any other point here or here, if an arc of a circle is made to pass through C and the pole, it will always fall within the arc of ST or ST1. That means all the poles within P dash and P double dash and P double dash and P dash will oscillate between T and T1 with the fulcrum as C. Therefore, this P and this solstitial color, as we have referenced it as the middle point, the point T0 will liberate from S to T while this pole is moving in this direction, and it will liberate from S1 to T1, S to T1, or T1 to S and S to T as the pole moves through this. Therefore, assuming that the point P moves around the circle within these two limits was considered by the Indian astronomers. However, there is a point by why this can this be generalized. For generalizing the solution of this equation, a solution of this libration, we will have to go through the solution of two right-angled triangles, spherical triangles. From the previous diagram, I have redrawn two right-angled similar triangles. The point C here, P dash and T, this is one arc of a great circle. P and S, this is part of the solstitial color. ST is the arc of 27 degrees. P dash represents the obliquity because it is the angle between the pole, equatorial pole and the equinoctial pole. So this arc represents 24 degrees. The point at which it cuts the circle, the two circles cut each other, is a right angle, and the solstitial color cutting the ecliptic is a right angle. So there are two right angled spherical triangles. Angles at TCS and PCP double dash are equal because they are opposite angles. And the segment PS is an arc of pi or 90 degrees, pi by 2 or 90 degrees, and the arc SC of this triangle is 90 minus PC. And these are the two spherical triangles which we need to solve. Now we have in two spherical triangles, we have the relations cos C is equal to cos A into cos B, sin A by sin A is equal to sin A by sin B is equal to sin C by sin C for all triangles. Sin C happens to be 1 on a right triangle. So sin A, where all these uppercase letters are the sides and the lowercase letters are the sides and uppercase letters are the angles. So the cosine of the sine opposite to the right angle is equal to product of the cosine of the two other sides. The sine of the angle, the sine of the side opposite to the right angle will be equal to sine of the one side by the divided by the sine of the angle opposite to it. So in these two relations, two right angles, triangles, we can write designating one of them as only the letters and the other one letter with a suffix I, 1. So cos C1 into cos I1 B1, etc. So from the previous diagram that we have seen, we can write this relationship. B will be equal to 90 minus C1. Angle TCS is equal to angle PCP dash. So A is equal to A1. A is equal to 27. The side A is equal to 27. And the side A1 is equal to 24. And the side CP or C is equal to C1 is equal to 90 minus B. This relationship we can easily write from that. Once that is done, we can solve the triangles. Using the relation sin C sin A by and sin C1 is equal to sin A1 by 1, we divide each by 1 by 2. Because we know that sin A and sin A1 are equal, A and A1 are equal, so we can cancel these terms and sin A and A1 we get. Sin A and A1 we get 27 by 24, sin 27 by 24. So we can get numerical values for sin C. Similarly, we can get numerical values for cos B. And cos C we can solve by using cos A into cos B, cosine of A into B, which yields C is equal to 51.24. And then solving again using the relation cosine of C is equal to cosine of A and B, we get the side CS, or the fulcrum point to the ecliptic is 45 degree 33, and the other arm up to the pole is 44 degree 27. Sin A by sin A, again we solve the other side and we get the angle is equal to 35 degrees. So we have two sides and two angles, we solve those. So we have two sides and two angles of this triangle CP P double dash, and by solving them using the relationship between the sides and the angles, we get this angle CPP dash as 63 degrees, and this angle being 63 degrees, this arc PP dash here is also 63 degrees. Now 63 degree is the complement of this arc, which is 27 degrees. And this arc is now 63 degrees. So this is a general solution for these two triangles. For any angle of limiting arc what you make, the arc through which the pole moves up to the limiting point will become the complement of the limiting arc which you have made. Here is a table which shows the computed values of the Ayanamsa as per Surya Siddhanta and the other school of thought which is on the Lahiri Ayanamsa. The Surya Siddhanta, as you know, takes 27 degrees of libration every 1800 years, so that it completes the cycle of libration in 7200 years. Whereas the Lahiri Ayanamsa considers it as a complete revolution, so it goes on from 0 degrees to onwards even after 1800 years. So you can see the 499 year. The year 499 was the coincident year as per our literature of the Hindu astrology. So in 499 the Ayanamsa is 0. In 2026, as on today, the Ayanamsa is 22 degrees 54 minutes. After 1800 years from 499, 2299, the Ayanamsa will become 26, 59, 55, which is around 27 degrees. And further onwards, after 200 years or so, you will see that the Ayanamsa has decreased. Likewise, from 499, if you go 200 years back, it has increased to 259. And another 15 years back, it has increased to 312 degrees. That means further increased. The 285 year 285 is considered to be the coincident year by the Lahiri Ayanamsa school. Therefore, it has completed 360 degrees revolution there on that day. And in 299, it has become 11 minutes. In 499, it has become 2 degrees 57 minutes. In 2026, it's at 24 degrees 12 minutes. there is a difference between the two Ayanamsa because of calculation methods. And after 1800 years, it is reaching 28 degrees, and then it is going on further 200 years in 30 degrees, 30 degree 48 or 49 minutes nearly. So here you can see that the computation methodologies differ between the two schools of Ayanamsa. So in the next part of the presentation, we will see something else regarding the movement of the Saptarshis, which is also very close relation to the principle of the axial precession. I hope this presentation would have given you a fair idea of how the ancient Hindu astrologers dealt with the subject of precession. I am sure that you would have liked this presentation. Thank you. Dhanyavad.